Welcome to Solving the Problem of Hunger, an examination of a Mexico-Indian history of scientific innovation. This lecture is a part of the series of public lectures and discussions organized by Science Gallery Bengaluru for its first digital exhibition, Phytopia. For Phytopia, we hope to bring together engineers, scientists, designers, artists, and biohackers to create an experience where visitors can experiment beyond the kitchen, the lab, and the farm. This program is organized in collaboration with the Bangalore International Center. A warm welcome to today's speaker, Gabriela Soto Laveaga. She is a professor of the history of science and Antonio Madero Professor for the Study of Mexico at Harvard University. Her current research interests interrogate knowledge production and circulation between Mexico and India, medical professionals and social movements, and science and development projects in the 20th century. Before we begin, I would like to remind our audience that Gabriela will be present for a question and answer session after this lecture at 7:30 p.m. You may post your questions in the chat box and we will pass them on to her. In the mid-1960s, concerns over population growth and the ability to feed a hungry world dominated global policy. The elimination of hunger via science, specifically agricultural science, was seen as a plausible solution. The global solution came to be known as the Green Revolution, and it was pushed from Mexico, where it originated, across the globe. Gabriela, you've done extensive research about this endeavor, and we are very excited to know what your insights have been. So over to you.
Thank you so much. I'm really grateful for this lovely invitation from the Science Gallery Bengaluru, and I'm very excited about Phytopia, and I will begin now. I will share my screen. So I want to draw attention to this particular image. As you will likely hear from often in these proceedings and from other speakers, plants have multiple lives. They feed, they clothe, they nourish, they heal, and give us shelter. Yet they also continue to be the focus of scientific inquiry. Today, I will focus on just one plant, a crop, wheat. There are few crops so often associated with mid-20th century development projects as is wheat. Hybrid seeds in particular, hybrid wheat seeds, were built to increase yields, alleviate poverty, and bring what was so-called modernity to the rural landscape. They held so much promise. Today, I wish to use wheat not as the point of analysis, but rather to use wheat as an entry point to analyze how we use plants to tell stories about the past. In particular, how we use wheat as the narrative of development, of national aspirations for not just one country, but multiple countries, and of course, as a source of scientific innovation. But first, I want to start with this image, which is one of my favorite images. And this is a field located in northern Mexico, but I call it a living library. And it is visible for only a few months out of the year. And what you see here, as far as the eye can see, are specific hybrid types of wheat. And as you'll see the first one here, it's a Green Revolution variety released and grown on millions of hectares in many countries, and it is still grown. Meaning that this is a seed that was developed in the 1960s and has continued to be tweaked. I'm going to return to this image because I want you to look at, from the first sight, it appears to be an image of diversification, of diversity, of crop diversity, honestly, as far as the eye can see. So I want you to keep that image in your mind because I will come back to it. I also want you to keep this mural on your mind. This was a mural that was painted by Diego Rivera. It has a very interesting story. It was initially painted as Man at the Crossroads and initially painted at the Rockefeller Center in New York. But he refused to take out Lenin, whom you can see on the right side, And it was destroyed in 1934 because it could not be at the heart of capitalism, steps from Wall Street in New York, and have this prominent figure of Lenin. He repainted it at the Palace of Fine Arts in Mexico City. Now, this is important for a reason that we will, and has a particular link to India that we will see later on in this talk. So, and finally, this is the third image that I want you to keep as I continue to give this talk. This is an image from the 1950s, and you can find in the Rockefeller Archive Center. And it was taken in the mid-1950s. And as you can see, it's a farm family, a Mexican farm family. And the idea is that it's farmers who will provide the world with plenty, and not just any type of farmers. These are Mexican farmers. So we normally don't think of farmers as those who are providing plenty or surplus. So the story changed significantly along the way. And it changed not just for how Mexican farmers were going to be seen, but also how farmers across the world were going to be portrayed as needing aid to produce the crops, the plants that they needed. And they wouldn't be independent. They would have to depend on foreign technology in order to continue to produce the crops that they had traditionally produced themselves. The narrative was going to shift. They would need aid in order to continue to do what they had long been doing. Okay, so to return briefly to this image, that change in narrative has a lot to do with how science perceived what crops could do and what they could produce over time and over space. So this is a story very much about time and space and how scientists were able to play with that when it came to plants and to make them travel across the world and fool plants into thinking that they were still in the same soil in which they had been created. But I'm really simplifying that, and I'll get more deeply into that. But first, I want to spend about 10 minutes or so giving you a background history of what the Green Revolution is, because this is very much a story of the Green Revolution, but I want us all to be on the same page, have a common background history to then understand a bit more of the story that I'm wishing to tell. So if you are to pick up a book about the Green Revolution, most likely this is the story that you will hear. And it's often repeated, so you may have already heard it. But the origins of the Green Revolution are often attributed to, or the roots, to a visit that former Secretary of Agriculture under President Roosevelt undertakes in the early 1940s to Mexico. And he decides to travel rural Mexico. And what he finds there, according to many reports, is incredible poverty. But most disturbing for him, he feels, and he comes from a farming background, and he feels that the farmers are not using enough technology or science to produce more crops, and that this can be shifted, this can be changed. So I have a bit of problems, as you can probably tell from this narrative. From the beginning, it's a narrative of poor people, poor farmers who need foreign aid. But this is, as I said, the story as it is told. In 1943, the Mexican government, together with funds from the Rockefeller Foundation, so funds from the Mexican government and the Rockefeller Foundation, they come together and they create the Office of Special Studies for the Mexican Agricultural Program. And the idea is to produce better crops that will yield more, but also will be more resistant to diseases, and ideally that they can help farmers produce more. Also, the arrival of the Rockefeller Foundation in Mexico will change how agriculture is understood or talked about in Mexico. It will no longer be an issue of subsistence agriculture that will fuel Mexico's dreams of urbanization and industrialization, but it will be this notion, but rather an industrialized Mexico, an urban Mexico, a Mexico that's able to export grains. So very, not subtly, the conversation shifts from those peasants, those farmers, subsistence farmers, to one of a more commercialized farmer who will be able to bring progress to the nation. This may sound familiar to some of you in India. But the story also shifts, and when you're reading the Green Revolution story, very prominent in the foreground are American scientists, American agronomists, and American politicians and diplomats. And this is something that with my India-Mexico project, I'm trying to push them to the background. They're still part of the story, and bring Mexican and Indian scientists to the foreground, because it was these scientists on the ground who were the ones who were doing much of the work. So it was really important for, in this map, the Mexican Agricultural Program, to deal with wheat diseases, because in particular stem rust could affect a field and destroy a farmer's crop completely. But also there was a problem with the type of wheat that existed in the mid-20th century, which was a wheat that could be found across the world, both in Mexico and India. And it was this very tall, very lithe, very elegant wheat. But it was tall enough, and when winds came, it could lodge, meaning fall over. So there was a very clear dilemma. How do you produce a wheat that is resistant to disease, but one that is also short enough to be resistant to lodging? So this was a puzzle, and you needed science, you needed experimentation in order to solve this puzzle. And in Mexico, there was a chain of experimental stations across the country, but there were two experimental stations that become really important for the study of wheat, and in particular, the ability for wheat to travel across the world. So one was near Mexico City in Chapingo, which was close to the National School of Agriculture, and the other one was in the north, bordering the Sonoran Desert. And both of these stations already existed, but with funding from the Rockefeller Foundation, they become very important. Why? Because by the 1940s, the world is divided. It's the Cold War era, and you're going to have a world that, as it says here, communism makes attractive promises to underfed peoples. Democracy must not only promise as much, but must deliver more. Asiatic and other underprivileged people attribute their present plight to the domination of the capitalist colonial system. In this struggle for the minds of men, the side that best helps satisfy man's primary needs for food, clothing, and shelter is likely to win. This is a report, an internal report from the Rockefeller Foundation. And what we see here is that the world is being conceived as capitalism will triumph if it can feed the world. So whichever superpower gets there first, so feeding the world now is really wrapped up into this Cold War narrative. And this is where, again, Mexico's experimental stations will play a really important part. How do you feed the world if you need to produce more? Well, agronomist Norman Borlaug comes up with this idea. And he says, it takes about 8 years, about 8 cycles of wheat for a trait to become part of the seed. What if we use Mexico's extraordinary microclimates? It has jungles, it has deserts, it has tropical forests. What if we use those and literally truck the seeds back and forth from the north, where you have Ciudad Obregón, with its climate that is very similar to the Punjab? Then we can take it to Mexico City, and in particular to Toluca, which in some ways resembles some areas of Tamil Nadu. So we can have these microclimates and work them to our advantage, because we would plant 2 harvests. We would harvest crops of wheat in 1 year. And instead of 8-year wait, we would reduce that to 4. So this shuttle breeding becomes incredibly important and successful. So successful, in fact, that in a matter of just a few years, the wheats that are being produced in these experimental stations are drawing the attention of not just American politicians, but Mexican politicians and also investors. Here's a picture of Vice President Henry Wallace with Mexico's Minister of Agriculture and a former Mexican president. And what's being shown here is the extraordinary wheat that is being produced in these stations. Do you notice how low it is? It's a dwarf wheat. You no longer have these tall, elegant stalks that could tip over, but rather they have developed these dwarf seeds, these dwarf wheats, which are closer to the ground but yield more grain. So you can see here the difference. The tall wheats in my left side, and then as you're going down to the different type of high-yielding hybrid wheat seeds. So the idea was to produce a series of varieties that are capable of out-yielding local varieties from Chile to Canada, from Minnesota to the Near East. Really important. Standardization. Create one variety that will basically carpet the world, because these varieties will be able to out-yield local varieties. This is really important, and I'm sure you will hear from other speakers about the loss of many crops and plants and flowers, and that from local regions which your grandmothers may remember, and which you may see images of which no longer exist. So here is the process. The beginning of this idea of standardization is good. This is the idea in the mid-20th century. We now see the complications in the 21st century of trying to out-yield local varieties. But here, remember, the push is multifold. Number one, to spread capitalism as opposed to a Soviet-style socialism, and also to feed the world, which is a huge concern. This is an image that was in Life magazine from the Bengal famine. Again, this image that so many of us are accustomed to, where you see the malnourished, starving child. And the idea with these images was to say there are some areas of the world that need aid, that need food aid. Do you see how this narrative is being formed? We can provide the food, and who better to provide food in the mid-20th century than Mexico, which has been producing so much of this hybrid seed. So what you have in the early 1960s, a massive famine is hitting both Pakistan and India. And the predictions are that as many as 17 million people could potentially die if they don't receive food or if they don't receive aid of some kind. So the Rockefeller Foundation, which by that time has been in Mexico for over 20 years and has been experimenting for a while, and the farmers around these experimental stations have produced so much wheat that Mexico is now exporting wheat to the world. So they decide to bring these hybrid seeds and make the largest shipment. I'm just going to go back one image so you can see this is the hull of the ships that are leaving the Mexican ports, and they are headed to what was then called Bombay. And you have these dozens of trucks that are going to these farmers to pick up these seed, to bring these seed and ship them off. And here, I just want to point, they label the burlap sacks that they're going from Mexico, from northern Sonora, and it's called the India Supply Mission. Do you remember that image of the Mexican family that would feed the world? And here they are saying it's come to fruition. You know, here are Mexican farmers and they are sending their seed to the world. So the idea of Mexico feeding the world. This is really important because let me just draw attention to that seed. Nowhere does it say Rockefeller Foundation, nor does it say United States, nor does it say US aid, which is a story that we know. So along the line, the tale gets changed. So the seeds arrive, and Norman Borlaug is instrumental in meeting with Indian scientists and Indian agronomists. And these seeds needed something that was very different. They needed more fertilizer, they needed irrigation, and basically they were going to change the way that India farmed. So within a very short time, this is an article from the Washington Post in 1977. So about 10 years after these seeds have been introduced. And here's what they're saying. It has been an incredible success. right? India used to produce 9.8 million tons of wheat, and 5 years later, it's producing 18 million tons. Pakistan used to produce 4 million, and in those same 5 years, it's producing 7 million tons of wheat. So if you are to look solely at yield, at production, then yes, this is a story of success. What we now know, hindsight, is that this wasn't a story of success. This wasn't a story of feeding the world. But within this sphere of the 1960s, there was this very clear fear of overpopulated world that would not be capable of feeding itself. You had books such as Paul Ehrlich's The Population Bomb, that warned that Malthus had been right, and that people were going to run out of food. And some of you may have seen this 1973 film, Soylent Green. And if you haven't, I'm going to ruin the plot for you, because there is no more food in the world. And the only thing that they can eat, as you can see from the poster, are other humans. So there really is this concern and this fear that overpopulation, the population rise, cannot keep up with the production of food. So Paul Ehrlich says the battle to feed, remember he wrote The Population Bomb, and he says the battle to feed all of humanity is over. Basically, it's lost war. Hundreds of millions would starve to death in the 1970s, he's saying, right? 65 million of them would be Americans, and India, he says, is essentially doomed. I mean, there's no hope. England, he says, will not exist in the year 2000. These are his predictions. And so things look quite dire. So when you suddenly have a plant, a crop that is mass producing, indeed, this looks like a story of success. So successful, in fact, that William Gaud, the USAID director, says, these and other developments in the field of agriculture contain the makings of a new revolution. It is not a violent red revolution like that of the Soviets, nor is it a white revolution like that of the Shah of Iran. I call it the Green Revolution. And so you have this idea that it's going to be science coming together with agriculture that is going to bring peace, that is going to bring plenty, and that it is going to feed the world. So, as I said, the Green Revolution was a completely different frame of mind, for, especially changing how farming, which had been done the same way for millennia, you suddenly had a lot of outputs. And by outputs, I mean irrigation, fertilizers, mechanization, pesticides, and most importantly, hybrid seeds, which needed to be purchased. Farmers could no longer reuse seeds that they had been using for the previous harvest that they would store and use again. And this would create a series of problems. Specifically, so the Rockefeller, when he goes to Mexico in 1967, it's billed as this great story of success. You see there John D. Rockefeller sitting in front of a map of Mexico. And it's considered such a success that in 1970, the Nobel Committee awards Norman Borlaug, the agronomist who had come up with shuttle breeding, and the agronomist who initially is contacted by Indian scientists and he goes, they award him the Nobel Peace Prize for his accomplishments in India and Pakistan, and for being, quote, the father of the Green Revolution, and for his role in ending hunger, to end world hunger by increasing the world's food supply. This is a beautiful story, right? And this is the story that we tend to hear. And it's a story of triumph. It's a story that's really colored with American triumphalism, American scientific innovation, and this story of American know-how and diplomacy across the world. It's become so much a part of that narrative that almost all books, The Man Who Fed the World, feature Norman Borlaug, and it's very much, as I said, a narrative of the United States. But in his address, Norman Borlaug says the following: It is the unusual breadth of adaptation combined with high genetic yield potential, short straw, a strong responsiveness, and high efficiency in the use of heavy doses of fertilizer, and a broad spectrum of disease resistance that has made the Mexican dwarf varieties the powerful catalyst that they have become in launching the Green Revolution. So the reason I wanted to highlight that is that he's saying the Mexican dwarf varieties. But at some point, the idea that these are Mexican varieties developed in Mexico becomes curiously disassociated from the Mexican scientist who worked on this and Mexico, the country, and become very much a narrative, as I said, of Norman Borlaug. This will become an issue in the 1970s when the United Nations Research Institute for Social Development says, you know, we have farmers in African nations, in East Asia, in South Asia, who are planting these high yield varieties of grain. Shouldn't we look into it to try to understand the social and economic consequences of changing a way of life, farming life? And it's happening so quickly in a generation. So they send out several researchers and they write up these reports. I think there are 14, maybe 18 reports. And the researcher who is sent to Mexico, Cynthia Hewitt de Alcantara, writes this extraordinary analysis. So she's there in the early 1970s and she says, these hybrid seeds are breaking the networks, the social networks. We have farmers that are becoming indebted. We have a way of life that is being pushed aside because of mechanization. And we have a rising class of seed dealers and bankers who are dealing with farmers who are putting them more in debt. We need to step aside and look beyond the crop to see what's happening in rural Mexico. What she was looking or thinking about for Mexico could easily be applied to India. So what you began to see with this embrace of the Green Revolution, immediately within a generation, you began to see environmental problems. Pollution, erosion of the soil, diminishing water sources, because remember, these have to be irrigated. Pesticide resistance, you needed stronger and stronger pesticides, and pesticides that would then be causing public health issues for the farmers themselves who were using these pesticides, often much more, and the same for fertilizers, than they needed to use. Social consequences, where you had small plot farmers who were now forced to purchase seeds. They were reliant on agriculture, reliant on industry, and it began to exacerbate regional inequalities. So what you see is that what had been seen in Mexico as happening as early as the 1960s, the seeds themselves weren't traveling alone. What was traveling with the seeds were also the social and political and economic problems associated with them. In India, I'm sure all of you have heard and are familiar with the farmer suicides. And if we trace the origins of these farmer suicides, we can go to these United Nations reports from across the world. Remember, these researchers found across the globe, and they're saying farmers are becoming indebted in order to buy seed. Farmers are becoming indebted in order to purchase fertilizer and pesticides, because now we have created a very capitalistic way of farming, which is hybrid seed dependent. And we have basically destroyed a way of life. But what was of interest to, and to bring it back to the plant, what was of interest to the scientists was they were searching for the true genetic potential of wheat. So that seeds that would be, as you recall, highly responsive to fertilizer and for irrigation. And remember that this is a narrative of success. It's so successful that the agronomist Norman Borlaug wins the Nobel Prize for the Nobel Peace Prize for what he has accomplished. And this is evidence that hunger can be tamed, that hunger can be solved via science. But we all know that Hunger is not a scientific problem. Hunger is a social, political problem. So what you had were scientists who were working on a problem that had been framed incorrectly. So also, remember that Mexico, those farmers in Sonora, in northern Mexico, those farmers become the model that will then be exported as well. But something that I didn't mention, I just said in passing, is that those farmers in northern Mexico were not the poor farmers that Henry Wallace had visited and took pictures with. The farmers of northern Mexico were commercial farmers. They were politically connected, economically stable, socially well-networked. They were not the farmers. So the Green Revolution does not start in rural South Mexico where you had subsistence farmers like the majority of the world. It begins in the north where you have a different type of farmer. But it's that model of farmer and farming that's going to get exported. So again, just a little, so the Office of Special Studies, its acronym in Spanish was OEE, peaked in 1956 where you had 118 scientists, 100 of those scientists working on these seeds were Mexican. And the reason I mention this, to go back to what travels with seeds, the socioeconomic problems will follow the seeds, but not the narrative of who are the scientists that are working with the seed. Because when the seeds arrive to India, the seeds will be known as Borlaug's seed, or they will be known as American Aid or the Rockefeller Foundation. And this becomes apparent when Octavio Paz, whom you may know as the Nobel Prize winner in literature in 1990, but in 1966, when the Mexican seeds arrived, he was ambassador to India from Mexico. So he was the ambassador in Delhi. And he was the Mexican official who would be very aware of these Mexican seeds that are arriving to India. And he very quickly, so here he is with, here's Paz with Nehru, and this is in Delhi in 1962. And Paz in the background, here he is with Indira Gandhi. And so this idea of Mexico and India relations are really being forged. Mexico would be the first country in Latin America to recognize India's independence. And it very early sets out to have one of the first embassies in New Delhi as well, because Mexico sees India as a sister nation. And in part because of their colonial backgrounds, and Mexico says we were under the dominion of the Spanish Empire, and our sisters and brothers in India were under the domain of the British. We were agriculturally based. We had aspirations to urbanize and to industrialize, but also to do that through technology and science. Very important. We have a harsh urban-rural divide. And he said, even physically, our people look the same. This is what Paz is writing about in his memoirs. He writes this book in light of India, in which it's this love letter basically to India and the years that he spent there. So Paz is there in New Delhi when you begin to have the arrival of these Mexican seeds. And he very quickly notices a problem. And he begins to write in these diplomatic memos. He says, interestingly, Mexico is never mentioned that they're the ones sending the seeds. It's often said that it's Norman Borlaug or thank you, United States. We want to thank the Rockefeller Foundation or the Ford Foundation. And he says, but I know that Mexican scientists are involved in this. Why aren't they talking about the Mexican scientists? And then he says, and also, why aren't they talking about the Indian scientists who are receiving the seeds and who are the ones who are doing the testing here on the ground? It's become a very narrow narrative of development aid. So much so that if you go back to northern Mexico, the main boulevard that takes you to that experimental station was renamed the Norman Borlaug Station. If you're staying in the hotel, which most visitors stay at, there's a Norman Borlaug ballroom. And the research station was renamed after his death, the Norman Borlaug Research Station. And every year there is a farmer's extension that the farmers come and learn, which is the Day of the Farmer. And if you see here, I guess it would be your right-hand corner, the shadow that you see there is that of Norman Borlaug. Deeply beloved, deeply respected, but also it's a very long shadow that really has narrowed this story. And at the entrance to the experimental station are the wheat, the hybrid wheats that were developed there. And at the back of this monument are a third of Norman Borlaug's ashes. He wished to be buried at the experimental station where so much of his work with different crops had taken place. So this idea of exporting, that Mexico feeding the world, really takes on a different role when we talk about the International Maize and Wheat Improvement Center, because it is here where seeds are being exported to the world. And I just put this in, it's not really related to the talk, but I thought people in Phytotopia might be really interested in this particular little factoid. So this is a picture from 2013, and it's Gates and Bill Gates and Carlos Slim, who at the time were the two richest men in the world. At the time, it was Carlos Slim, a Mexican. And it's the inauguration of the Biosciences Complex at CIMMYT. And the idea was that we are entering a phase where water is going to become a problem for the world, that we will be an overpopulated world and there will not be enough food to feed the world. So we need to come up with new agricultural solutions to feed a hungry world. Does this sound familiar? Because I just told you about this, about the 1940s and 50s, and especially in 1960s. So here we're in 2013, and what they are inaugurating is a biosciences complex, which will be focused on studying not just diseases of plants, but ways of creating better, stronger seeds to deal with the coming drought that we will all be facing in the future. So these seeds, it comes back to developing, and again, science at the center of the solution to feed the world. This is a terrible picture taken by me. Sorry, it's fuzzy, but these are seed packets of these seeds that are being developed that are sent for free to any farmer anywhere in the world that requests them. But also, it's not just about sending seeds, it's also about training scientists. So every year, hundreds and hundreds of wheat scientists come to the two research stations in Mexico to learn how to think about wheat, to basically create a wheat science mentality that is then spread across the world. And they are known as the wheat apostles. At least that's how they were termed in the 1960s for Norman Borlaug. So we've spent a lot of time right now in Mexico. We need to now go across the world. And I'm going to take you specifically to Ludhiana in the Punjab. So if we were to create a line between Ciudad Obregón and the Punjab, do you see this map here? What do you see? You will probably see that Mexico and India line up in more ways than Octavio Paz told us in his book. The commonalities are beyond cultural, and they are beyond, they lie on, in many, many parts of the countries, on the same latitude. And this is important because Sonora, and you can't see where I'm pointing on my screen, but Sonora is within the same degree, within a variation of degrees of, lies within the Punjab. Now, this is important because what did not travel with the seeds was an idea that had been fermenting in Mexico for many years, that agriculture, and agronomists in particular, had to have a social bent, that you couldn't have a capitalist idea pushing farming. You couldn't have farmers who needed to be buying shovels or seeds or other, that you needed to create a bond with the farmer, and it would be a bond between science scientist and the farmer. That bond is lost when we begin to have more of a capitalist idea. So you begin to hear less and less of an influence from these Mexican agronomists when the seeds travel. This is especially sad, a sad thing, because some of these agronomists, or at least one in particular, was an Indian. So here is the Yaqui experimental station that I had spoken about. And Mexico had this long tradition of experimentation well before the arrival of the Rockefeller Foundation. And in particular, do you remember the Norman Borlaug experimental station of the North? The experimental station of the South is of great importance, because in the 1920s, an Indian refugee named Pandurang Kankoje, whom I know you have in Phytopia several images of him, he arrives at the National School of Agriculture. And the reason why I want to focus on him is because if we focus on Mexican agronomists, whom I won't today, but also if you focus on a figure such as Kankoje, the origins of the Green Revolution are not capitalist. They are instead socialist in nature. And they are influenced in large part by the desire of in particular, one Indian national to throw off the British Raj and to become independent, and to use his knowledge of science, to use his knowledge of plants, and to use his knowledge of society, and especially his deep sympathy toward farmers, to try to create a new society, a new world. And he does that not in India, where he could not be, but he brings those ideas to Mexico. So you're going to have this very curious coming together. Mexico, which has just gone through its revolution to overthrow large landowners, and you have the peasants who are rising up, and you're going to have agronomists who are going to have a new agronomists who understand plants, who deal with crops. And in the midst of this, an Indian arrives to the National School of Agriculture. And what he sets out to do is to work on hybrid crops. He's going to be interested in particular in hybrid corn. And Kankoje is a really fascinating person. He's constantly trying to come back to India, or to go back to India. And he can't, because it's not until after independence that he will be able to go as an elderly man back to India. But while he's in Mexico, he's working on these new types of crops. What new types of crops can be given to farmers, but more importantly, and this is what really excites me, he teams up with several Mexican politicians, artists, and they create a free school, which is going to be a free school for farmers, that's going to be socialist and anti-capitalist in nature. And the idea is that through science, that they will teach the farmer how to create better crops. They won't ask the farmer to pay for seed. They won't ask the farmer to pay for their education. It will be provided. And so what you see here, and it's a little hard, but Kankoje is standing right above the farming implement, and the rather robust man is Diego Rivera, the muralist, whom Kankoje had met when Diego Rivera goes to the National School of Agriculture to paint a mural. And they begin to talk. And Diego Rivera is so fascinated by this Indian in Mexico that he says, "Oh, what are you working on? Do you remember this mural?" So if you look at the front, so remember this mural is about a man who has learned to control the universe by understanding the skies, by understanding diseases, but you can't have any of that without first understanding crops. And that's why you see plants at the front. Before physics, you have agriculture. And this is what Diego Rivera is trying to say. But importantly, many of the crops that are showcased here were some of the crops that Pandurang Kankoje was working on in his laboratory. So portrayed in this amazing mural is the power of Kankoje. But also in the Ministry of Education in Mexico, this there's this wonderful mural, and it's called Our Daily Bread. And at the head of the table, breaking bread and feeding the world, which is represented around the table, both elderly and young, and from across different socioeconomic classes. Remember, this is in the center of the Ministry of Education. At the center, the person who feeds the world is Kanduran Kankoje. So you have this wonderful image of this recognition of, of Indian science and Indian beliefs within the Mexican School of Agriculture, but also, and what you don't see here is the networks that Kankoje was able to work together within the agronomist. So here, very quickly, this is each of these lights. So what happened to these farmers? Do you remember those farmers that had been part of this discourse in Mexico? In Mexico, these farmers embraced technology to a degree that if you go there today, they have an office or this institution that's called Central Command, and they are devoted now to preserving water. So each of those little light bulbs that you saw is a well that is monitored electronically and in real time to show how much water is in the valley. So it's just, these are farmers who control this knowledge. This is farmer innovation. They have moved beyond agriculture and have created a space in which the science that they are producing is helping them to build better crops, but in a much different way. So this idea of agriculture emerging together with science to produce better crops. But if we move again from Ciudad Obregón and back to India, in particular to the Punjab, what happened to those seeds when they arrived in India? So something really interesting. India, shortly before the arrival of the seeds, there had been a series of agricultural universities created in India. And the goal of these agricultural universities was multifold. In particular, it was to sponsor agricultural research, but also to teach and to extension, to bring knowledge, science to farmers. But you couldn't just do this within the universities. You also needed to create something that wasn't contained within the walls of the university. And this is where the KVKs, or the Krishi Vigna Kendras, come into play. So do you remember how in northern Mexico, you have the farmers who have become independent, have created their own science. In many ways, these KVKs, of which today there are more than 600 throughout India, divided into 8 different zones, most of which depend on agricultural universities regionally, but they also depend to the ICAR. And the idea was that agricultural universities would provide the technical services, the demonstrations and technology transfer that was needed to create better farming technologies and knowledge, not just about crops, but also with animals and gardens and a series of other. So in the last few years, I've been visiting a couple of KVKs. This is in the north of India. This is in Jalandhar farm. And the solutions that Indian farmers are coming with are extraordinary. They really are as amazing as the ones that we are seeing in the farming communities in Mexico. And I'll just very briefly, because I know I've gone on much too long, what you see here is a chicken roost, but you also see a pond of water, it appears. And when the chickens, it's a grate at the bottom, so when the chickens defecate, it goes into that water, which is then used to water the nearby crops, thus creating natural fertilizer in the water to already provide, and it becomes this ecosystem that is working together, trying to avoid the purchase of fertilizer, trying to use everything and go back to this sense of a system that worked together. The system in which everything was used and reused and recycled, and that nature itself was creating the system and not the need to be purchasing, which was this idea that was really ingrained in the mid-20th century. So, as I said, what happens if we change the story and we don't think of this arrival of seeds as development aid, What if instead we focus on the local and localized innovation? And I think if we go, for example, in the case of India, to the KVKs, it's there where we begin to see how Indians were able to innovate with the seeds that were coming from Mexico, and they stopped being Mexican seeds. They still had Mexican origins, but they were transformed into Indian seeds because they needed to meet the local needs of Indian soil, of Indian and a different Indian ecosystem. So here's another KVK, and this is in Tamil Nadu. And what you have here is another case of, if we look at the local, if we look at local science and local farmers and local communities beyond this narrative of US innovation, we come up with very interesting solutions. So here on the left-hand corner, that is an Indian farmer who's showing me on his cell phone that he only produces organic crops, organic food, and he was having problems delivering it. So he was able to, the ingenuity is amazing. He says, so I bought a truck and I decided that I was going to cut out the middleman and that I would be the purveyor of my own crops and shuttling them around. And so when I interviewed him, I said, so what was the business plan? He says, I don't need a business plan. I know it was going to work because people are hungry. They need the food. It was going to work. So this notion of importing different ideas and different models, in a way, what the KVKs were trying to do was not rely on imported models of technology and imported knowledge, but rather to create its own knowledge. The KVKs have, of course, they've had a lot of problems having to do with funding, with centralization of knowledge, creating hierarchies of knowledge within farming communities, focusing on some farmers versus others, focusing on some crops over others. So we can't again, we can't give a papered over vision, but the idea of the KVK in and of itself, I think, is a really fascinating one because it shows, again, the diversity of microclimates in India, the diversity of knowledges that still thrive in India, the diversity of crops that can be marketed outside of traditional systems, and the innovation that exists among Indian farmers. And all they need is, for example, a truck in this case. And then you can then yield and produce more. It's not the grand scale of a global capitalist world, but it's on a scale that can transform little by little, incrementally, the world by using one crop, one plant. And with that, plants take on a different meaning. They take on the local meaning, and they don't become this narrative of a green revolution, but rather a localized narrative in which the plant has a lot more meaning because it's created by someone for whom the crop means something completely different. Thank you.
Thank you so much, Gabriela. That was a very fascinating lecture. The sort of, I think it's safe to say that a lot of us are unaware of the multiplicity of stories and histories that actually go behind the idea of solving hunger in the world. And thank you for reminding us of the revolutionary roots of the Green Revolution. Thank you so much, Gabriela. I'd just like to remind our audience that our speaker would be available to take your questions at 7:30 p.m. So don't forget to tune in for that conversation. Thank you.
Thank you so much.